Good afternoon, everyone. Welcome to the second part of our annual meeting at SmartChain project. And this is our third webinar and our second stakeholder online webinar related to SmartChain dissemination. And today we're going to have two members of our project, Nina and Ali, and they will be talking on the general theme of circularity and global value chains. I will stop sharing, and as we had agreed, it will be the turn of DTU to start. We will take a few questions after each presentation, and hopefully we'll also have time at the end to have a more general conversation and discussion after having heard both presentations. Okay, so I'll stop sharing and I'll give the floor to Ali.
Hello, everyone, and thank you for being here. So first, I want to introduce myself, and I'm a postdoc researcher at Technical University of Denmark and working with Alan on the SmartChain project. This is the title of the abstract that we had a presentation for that in the Hamburg conference in the Sustainability Forum. And so I will start by just have a short introduction of the project. I know everyone know about this, but this is the SmartChain project, and the aim of the project is to enhance the sustainability in fisheries and aquaculture value chain by developing some approach and tools for sustainable utilization, production planning, and logistic optimization. And so this is a multidisciplinary project, and we have some partners that you know everyone. Then our role in this project is to develop some optimization model and develop a simulation framework for that. On the first side, we had some optimization model for the production planning and logistics optimization. But now we focus on developing a simulation framework, and where we create a framework to assess scenarios for enhancing the sustainability performance from farm to fork. So you can see the value chain of seafood in the right side, and it starts from transportation problems, then we have the supply chain problems, and then we have the business analytics problem. Then we can find that each of these problems can affect each other. And for example, the quality of the fish that are landed in the harbor can be influenced by the transportation problems, and then the quality will affect the supply chain cost and supply chain sustainability. So if we want to consider all these interactions, then we will need a simulation framework where we work on it, and we use the system dynamics approach for that. So we know that the growing of the fish and loss that based on the FAO estimates that it's about 35% of fish that are harvested from oceans and lakes and fish farms are wasted or lost before they ever reach a plate. And the 35% is equal to almost 3 billion Atlantic salmon. And in the Europe, it's mostly on the fisheries part, distribution part, and consumption. So we need to do some work to reduce the loss and waste and have some strategies for that. Then we know the concept of restaurant material loss, waste, and byproduct. Just a short, for giving a short introduction for that. The restaurant material referring to the residual material after removing the edible parts, commonly the fillet. And if we use the restaurant material to have some value-added items, then we call it byproduct, and it could be animal feed energy, collagen, or pharmaceutical items, or something like this. And then we have the fish loss and fish waste. The fish loss is referring to the decrease in quality and quantity of the food resulting from decision and action by food suppliers, excluding the retailer, but the fish waste is referring to the retailer level and service and consumption stage. So these are the byproducts, and we considered some of the byproducts in our system dynamic model. Then we consider a generic seafood supply chain before starting our model. And the generic seafood supply chain is referring to the supply chain that's forward logistics and backward one. So the fish are coming from the sea, or they could be sourcing from the aquaculture farms, or they could be imported from other countries. Then the fish could be sent to the processing companies, or to be packed there, or to be processed there. And then they will need to be sent to the warehouse or wholesaler. And from there, they could be exported, or they could be directly sent to the retailer. And as you can see, we have a lot of restaurant material and loss and waste in this value chain. And if we collect this restaurant material and waste and loss, and just send them to the recycling and restaurant material processing site, then we can sold them to the retailer and use these restaurant materials. Then, based on this generic seafood supply chain, we have our study, which in our study we focused on the whitefish supply chain in Norway and Iceland, and we analyzed the losses and waste in processing and transportation and retailer stage of the whitefish, specifically the codfish. And we considered some sustainability criteria. We have different sustainability criteria to evaluate the sustainability of the seafood value chain, and we use the sustainability criteria that provided in the work package 3, I think. Then we have a methodology for our study, which is simulation and using the system dynamics for that. And why we use the system dynamics is that we want to model the interaction between the variables that we have in the whole whitefish value chain. So you can see at the right side of the slide that we have just considered the fish that are harvested from the sea, and we didn't consider the aquaculture farm or the sea or the fish that are coming or imported from other countries. So this is the value chain that we are working on it now. Then in the next slide, I will talk about the food loss waste that we considered and the sustainability criteria that we are considering in our study, and then about the methodology that we are using. So we have some drivers for the food loss waste in the seafood industry, specifically the Norway and Iceland, and we use these drivers from the work package 1. So we have some waste regarding the spillage, or some issues in production planning, storage, and logistics, or some issues regarding the overstocking and overordering, or poor catch technology and lack of technological solution, or financial incentives. We try to consider some of these drivers when we want to develop some scenarios and study some scenario in our study, but we didn't consider all of it in our study now, and maybe we will consider in the future. So then about the sustainability criteria that we considered, so you can see that we consider the resource utilization, CO2 greenhouse gas emission, food access, the profitability, fish loss, and resource conservation, and fish waste. But I have to mention that some of these metrics could be categorized in more than one aspects of the sustainability. For example, the resource utilization could be categorized in both economical and environmental aspects, and while the resource conservation could be considered in the environmental and social aspects. So we can say that the defined sustainability metrics can support another aspect of the sustainability. Then we have the methodology, and we use the system dynamics approach for that. And we know that the system dynamic approach relies heavily on the quality of the data set. So first we needed some data. We used the catch data, the seafood processing data, and consumption data. And then we needed the mapping of the structure of the system. So we used the work package 1 for mapping the structure of the system. So we had the supply chain mapping report, and we used the flow of mapping and production steps. Then by using these data, we try to build our causal loop diagram when we try to determine the variables in our system, determine the interactions between them, and then try to find the feedback loops that, because we want to model the dynamics of the system, so we need the feedback loop for our study. And after that, we built our stack and flow diagram to have some simulation time-based modeling. And then after building the stack and flow diagram, we had some meetings and interview with Gudrun and Nina and Magnus to validate and verify our model. So we did a validation in the first step, and so we got some feedbacks and then tried to revise our CLDNS and the stack and flow diagram. Then after the first steps of validation, we tried to develop some scenario and evaluate our system. So this is the methodology that we have used now. And then I want to talk more about the methodology. So we first need a dynamic hypothesis. So we can say that the whitefish supply chain is a multidimensional problem influenced by various endogenous and exogenous variables. So you can see the system boundary in the right side. So and we categorize our system into 4 modules, from fish and restaurant material supply, the processing side, the retailer side, and finally the restaurant material processing and recycling. And you can see the interaction between these modules. And then we have some variables, the exogenous variable and endogenous variable. The exogenous variables could be the fish catch, consumption, price, cost, and environmental measures. But we have some endogenous variable from the quality of the fish, the level of the technology, and some taxation and limitation on disposal that we consider in our scenarios. So based on the hypothesis and boundary, we try to build our causal loop diagram. So we had some assumption for our simulation. The main process in our system or in the system dynamics that we developed is gutting and filleting. So we consider just gutting and filleting now as the primary process. And the product types are gutted and fillet fish, so chilled fish and fresh or frozen fillet. Then the main restaurant material that we are considering in our system dynamic model are liver, viscera, head and tail, and skin. And then we assume that the restaurant material could be used for production of fish meal, fish oil, collagen powder, and canned liver. We consider a waste management policy, and so we assume that the waste at retailer level can be repurposed for donation or used for biogas production before disposal in landfill. We consider some limitations for that. I will talk about it more. Then we have the causal loop diagram. Just I want to mention that we have 4 modules: processing level, retailer level, fish loss restaurant material processing level, and emission and water consumption. In the processing level, we assume that we have some balancing group and reinforcement loop in the system dynamics model. And I want to just talk about these loops in our system. For example, the reinforcement loop is referring to something like if we start from the remain quota variable here. I don't know, I can add my
Zoom or
yeah, here. Yes. If we see that remain quota, we start from the remain quota. And if we have more remain quota, it means that we will have more fish to be processed. And more fish to be processed means that we will have more gutted fish or fish fillet stock. Then we can sell more, or we can export more fish. So then we will have more income. And more income means that we will have some more demand, and more demand means that we will have to order more fish, and ordering more fish means that we need to buy more fish, and buying more fish means that we have more fish to be processed. Just it's like a reinforcement loop, and it's increasing over the time. But if we had the same way from the remain quota, but in the fish to be ordered variable, then the more fish to be ordered means that we will have less remain quota, and it's a balancing So these are the loops that we have in the causal loop diagrams, but I can talk about it more in the simulation model and the stock and flow diagram. So we have this nice picture. I do not expect you to find out what's going on in this system, but I try to explain more the subsystem that we have in the stock and flow diagram. So it starts from the sourcing part. The fish are landed in the harbor, so they could be gutted or they could be in whole shape. So if they are in the gutted shape, they can be sent directly to be packaged and then exported. Or if they are in the whole shape, then they should have some process on land like gutting and filleting. So the gutting on land and the filleting on land subsystem are supplied by the fish that are landed in the sourcing part, in the sourcing subsystem. Then we have the gutted fish or fillet fish here in these subsystems. And after that, the processed fish could be sent to the warehouse and the storage part. Here we have some demand. We want to satisfy the demand, so we consider that demand could be from other countries. Then we will need to export them, or could be in the domestic market, which we consider retailer for that. And the fish types could be in chilled fish, or could be frozen and fresh that are exported or sent to the domestic market. Then we have the retailer part, and we consider the domestic retailer. And as I told before in the previous slide, we consider that the unsold fish could be donated or could be sent to the biogas production site or landfill site, which I will talk about it more. Then we will have the restaurant material sources subsystem. So we can say that the restaurant material are coming from the gutting process or filleting process, or they are coming from the onboard processing. And also we consider that some of the restaurant material are coming from other countries after the export of the fish. So this subsystem is modeling the restaurant material sourcing. Then we assume that we can use the restaurant material for production of the liver can, the fish meal and fish oil and collagen powder. And so this is the restaurant material processing subsystem. And finally, we consider some of the metrics, sustainability metrics to evaluate our system. So like the food access, greenhouse gas in production, and water consumption again in the production, and the lost sales as an economical aspects. So this is the simulation model, and I have to mention that we used a lot of equations and formula in each of these variables, trying to calculating these variable and their interactions. Then we used some data for running our simulation. We use now the Norway's cod fish landing data for 48 months from 2020 to 2023. And we consider that the landings are the whole fish, gutted with head, headed and gutted fish, and fillet with skin, and skinless fillet with bones. And we estimate some of the data from papers that was published in 2024. And we use some of the data for the retailer demand from that paper, and estimate the export of the fish in Norway, and just do some estimation. Then we consider that we have a domestic retailer which is responsible for the significant fresh and frozen fillet demand in Norway. So these are the data that we have used for running our simulation model. Then we try to do some simulation scenarios. The first one is to investigate the fish quality impact on the food access. Then we try to investigate the fish quality impact on environmental metrics. Then we try to put a limitation or enforce the fishers to bring the restaurant material to the harbor. And the last one is to avoid the over-ordering of fish by retailers. These are the scenarios that now that we have worked now. The first one is about fish quality impact on food access. So we assume that the fish that are landed could be in high quality, medium quality, and low quality. And then each of these quality has a different yield rates in gutting and filleting process. As you can see the amounts in the first row. So and then we consider three scenarios. In the first one, we assume that the fish that are landed are in the high quality in all of the 48 months. For the medium quality and low quality, it's same. And then we calculated the total processed fish, the whole chilled cod fish and fresh and frozen fillet tons in 4 years. And as we expected, the amount of the processed fish, if we have it all in the high quality, would be more. But we tried to calculate this difference, and it's about 17,000 tons of fish. So we can say that instead using these fish for human consumption, we have to process it as restaurant material. And for making it more sense, we assume that the retailer demand is approximately about 1,000 tons of fish. So it's equal to 70 months of a retailer demand for the medium quality case, and it's gets bigger when it's in the low quality case, and it's equal to 33 months. And then we try to consider a conversion rate for that and try to calculate the whole cod fish that we need, and it's not an amount that could be ignored. So we can say that the lower quality of fish landed leads to fewer fish that could be sold by processing company and more fish that should be cut. Then we had another investigation on fish quality impact on the environmental metrics. So we just compared the high quality case with the low quality case, and you can see that in both cases we have increasing both in greenhouse gas emission and increasing in water consumption. In the first figure about the increasing of greenhouse gas emission, we can say that it can vary between 3% to 80%. But I have to mention that it's just regarding the fish primary processing and warehousing, and we didn't consider other sides like fishing and else. We just considered the energy consumption in the greenhouse gas emission in processing and warehousing. But so we can see that we have some peaks in the peak months. So we need more electricity and more energy. So we will have more. We need more. We will have more greenhouse gas emission. But if we want to talk about the increasing in water consumption, I have to mention that the increasing in water consumption is influenced both by the quality and also the demand that we have for fish, because for having more demand means that we need more ice to preserve the fish that we want to export or sell to the domestic market. So we can again say that the fish quality can have a high impact on environmental metrics too. Then we try to consider another scenario. We put a limitation on the amount of restaurant material that should be landed to the harbor. So we use the feedback loops for that, and we put a minimum threshold level for the restaurant material that must be landed. And then we vary these thresholds from 0 to 1. The 0 means that they don't need to bring the restaurant material to the harbor, and they just can bring the fish or the processed fish to the harbor. while the one means that they need to bring all of the restaurant material to the harbor. And then we did a study for that, and we can see that bringing all the restaurant material to the harbor will increase the potential biostream products about, in average, about 150%, but we will have approximately 30% increase in the average lost sale. So it's up to the policy and manager, and they should do something to have a trade-off for that. Then finally, we have the last scenario that we considered to avoid retailer over-ordering. According to The Guardian, the retailers are responsible for about 16% of wasted seafood in the USA, and I think it's could be same in Europe. So we assume that the unsold fish in the retailer pot could be donated or could be sent to the landfill site or biogas production site. But we consider the landfill limit and a limitation for the fish the unsold fish that could be sent to the landfill site or could be sent to the biogas production site. And we try to force the retailer to ordering less if they can adjust their order, because they have a confidence level for their order and they want to always have some fish in their warehouses. But we try to do some penalty for that if they exceed the fish that could be landed to the harbor, to the fish that could be sent to the landfill or the fish that could be sent to the biogas production site. If they exceed this limitation, they have to pay some penalty, and this penalty means that they have to adjust their confidence level, and then we run our simulation and with some data, and you can see the result here. So over the time, first the waste that are sent to the landfill site and are increasing over the time, and then when they are approaching to the limitation on the quota, then they will try to decrease this. And the interesting point that is they are tend to decrease their confidence level to the minimum level that we have defined for the confidence level of the retailer. And then they will decrease their order for the processed fish. So these are the scenarios that we have considered now, and so we can have some findings from the study now. So we can say that the one key factor is the quality of fish, which can significantly impact the food access and CO2 and water consumption. So then we can say that we need to consider some motivation policy or regulation to increase the bringing of restaurant material to the harbors by fishers. I think it's for the Norway case, I don't know, because I think we don't have it for the Iceland's case. Then we try to, we can say that the avoiding overstocking and overordering helps reduce the excessive fishing pressure, which is crucial for maintaining healthy fish population ecosystems. Finally, I want to talk about our future works agenda. So we need to discuss this result with practitioners and policymakers for more validation and for maybe we can get more scenarios for our study. We need to perform the simulation model for Iceland and compare the result with Norway case, and then we will investigate more scenarios for enhancing the sustainability measure, and we are welcome to your comments for having more scenarios. And finally, I will have this nice picture that is made, and I think it's made by AI, and I welcome to your question and comment. Thank you for listening.
Great, thanks.
Thank you very much, Ali. So now we open the floor for some direct questions to your work and presentation. Anyone would like to kick off? Gudrun, you're muted.
Yes, I'm muted.
Yeah.
And I have a quick question. Just I missed it in the how you define the quality to start with, Ali. Is that the yield basically, or
now we have considered as a random variables for the quality of fish, and then we change the random variable and do some analysis based on the random variable for the quality, and we consider that the fish could be in the three level of quality, but now we just consider the random variable for that as an input for our model.
Yeah, and a random variable, which is in the what kind of distribution?
Yeah. We use the beta distribution for that, and then this quality will affect the yield rates for filleting process and gutting process.
Yeah, I guess I understand, but it's just that the quality to me is always the time passed since catching.
Yeah, probably most, but I mean, it could also be other things. So
yeah, of course,
damages and parts of the population that are semi-dead already in the sea, or I mean, diseases, so on.
Yeah, I understand it. It's the assumption that you make. That's fine. It's a distribution. Yeah.
Yeah, exactly. I mean, we need it as a quantity somehow in order to have, you can say, one-dimensional quality index, and that's why it's been defined as a yield percentage of a. So the yield percentage of a total volume. So whenever you have 1,000 ton, then if it's a yield of 65%, then you have 650 kilo.
Yeah,
but you also have like quite a big share going to conventional production in Norway, like 50% of the raw material, and then where you also have like the packs, the cold bags is quite the normal fraction to pick up. It's quite significant as well. I just saw that you didn't include that. Maybe that can be something to include as well. Because we can look at it tomorrow.
Yeah, certainly. So that would, so whenever you take 1,000 ton, you would take the 50% out first, or
yeah, you can say that about 50% annually is going to this conventional, this saltfish or clipfish or subfish production.
Yeah.
And that happens in Norway, and it's not actually being done in abroad, the process.
Mm-hmm.
Yeah, that's something that maybe to go into to define a little bit more precisely.
Yeah.
Thank you very much for your input, Gudrun. Anyone else from the either Copenhagen or the virtual floor would like to do a follow-up question?
We could ask you a question then. So in the audience, what would you think, now you saw a couple of examples of what do we call scenarios or use cases that we were looking at. Which one would you think are most interesting for us to examine?
Maybe you can put the slide again if you have that. I remember that you had one. Maybe you can go back and yeah.
Those dishes are very Norwegian.
Actually, you could, the one with the,
I know
what's it called there?
Exactly. I think that it's easier.
Go into the last one.
You would not?
No,
Because
it's a mess.
yeah, it's a mess. Yeah.
Yeah, I don't think it's that interesting. It's more interesting because they can't use like the waste today, at least not in Norway, I think. They just have to throw it away.
Yeah.
Yeah.
I would start earlier in the project.
Yeah. But yeah, I see that. But on the other hand, wouldn't it exactly be the reason for studying it? Because if you are, what is it? Is it an EU? You have to help me here. There's a new EU rule saying how much food you can actually waste from maybe that's more on the production side, or is it also at the retailer level? It's only at the production side, I'm not sure. But there's a completely new thing, which means that so one of the supply chain people that I work with, no, you know him. There are other group, Visa and Simon knows him. From Deloitte told me about that they work with Arla, and for the dairy production, they basically cannot waste more than a certain amount of material or volume every whatever month. And that means that they need to do something else than what they used to be doing. So that's basically a cap or something like. So I don't know if that's going to happen for the retailer side. If there's anything changing on the retailer side, or if it's just
I'm not sure. I'm not sure.
Just trash it, and then it's biological waste, and it goes to the bioenergy, and then it's fine.
Yeah, this is the EU, right?
Yeah.
We're looking at Norway.
Yeah.
We're going to
Yeah,
follow.
I know.
We're following anyways,
Yeah.
probably. So, but I don't know about it.
Yeah.
We can look into it.
Yeah. Well, okay, fine. We take the point made. What about the other slide where you have the
But like the bringing the
the nine? This you had the table with the
regular
different ones.
Yeah, quality.
No.
No. Which one?
Back.
It's not good. Not working. Yeah.
Just have to go back. That's the one. Next one. Next. This one.
Yeah.
Exactly. I think that could be like inspirational to whatever analysis could be made.
But we have them split up in Norway and Iceland.
Yeah. Yeah.
So you can separate it.
Yeah.
But they will probably be overlapping.
Yeah. Are there any here that so let's say, for instance, the overstocking overall, and we down prioritize that one. Are there any of them, the other ones that we have to bump up to be?
Like that, bringing the RRM to the harbor, I think the only solution in Norway is to regulate. Because as long as it's not economically viable, they won't do it. Period.
No. And then at the same time, parallel to this, Gudrun and also I guess Nina and the rest of you from Iceland, or anything that we didn't have in this one, or that we should prioritize higher if we look at the Iceland case?
Maybe there's an echo. Maybe the point that to look into fresh versus frozen products, which means that if you have more frozen products, then the overstocking, overordering is less important because there's a longer shelf life. So if you could kind of have scenarios on one part fresh and the other frozen, and then what is also following is that the distribution will be different with frozen products rather than fresh. So there maybe that would be an interesting scenario to look into, and having and keeping in mind the different production planning, of course, and spillage, etc. But basically to look at those differences. Fresh
Yeah. Yeah.
I do actually have a question or kind of a comment. I'm quite interested in this poor catch. Oh, I'm sorry, is an echo?
There's an echo.
Yes. So this driving her poor catch technology. Have you seen any differences between the two countries? Is this a problem because of the technology used in the boats is not sufficiently good? It's because the vessels are not up to standards, updated. I found it quite intriguing. Not sure. Yeah, you are all muted. Yeah.
That is also an interesting scenario for you to look into, the different vessel types in Iceland versus Norway, as we have discussed earlier. Because in Iceland we have decided to have more land-based processing, whereas in Norway you have those big trawlers that are freezing on board. So that there are differences in the vessel types, which impacts also the quality or the different type of processing, more land-based processing and more value added in Iceland versus in Norway. So those are also key differences that could be made into different scenarios to look into. Type of vessels, yeah.
Yeah.
I don't think they're following us in
I don't think so, because they're muted. We always need to mute.
They're discussing. They're not listening to.
Not discussing, we're just listening. But we hit the microphone and you get an echo. Yeah, I mean, I don't know exactly how to do that with the technology. We talked a little bit about it before, I remember, and it was also in the early stages of the causal loop diagram.
Yeah.
And right now it's not hard, right?
Yeah, but we can, yes, but if we add the fishing side, then we can consider this as a scenario.
Yeah, so the technology side, I mean, yeah, I don't know if you could do a comparative analysis based on this, because there are so many insecurities here or uncertain data, but at least you could maybe not compare it, but you could do two different types of analysis.
You have the data.
Yeah.
For Norway at least.
Yeah. So we know, what do we know? We know if it's a frozen trawler or is a freezing trawler. Called,
yeah, you know the name of the vessel.
Yeah.
We know what the vessel is.
Yeah.
And you know the quality of the landings.
Yeah.
And the species.
Yeah.
And the time. And the catch area. I don't give more.
This is known for both Norway and Iceland.
Do you get this in Iceland as well?
Sorry?
Do you get the same data for Iceland?
We get the landing data from each trawler. It's yeah.
Yeah.
And then what did you? So what was that the SIGAs are not then getting from the fish or Stufa, sorry. So they get the landings and but they don't get the temperature of the fish being landed.
No.
And they don't get.
They have the seawater temperature.
That they do have.
Really?
I mean, yeah, but that might not have it in Fiskestoffer, but they have it in one of the other sites in the weather site. And what more is it that they need?
But more about the temperature of
The temperature of the fish, of the catch, when they landed. Yeah,
And the duration of the trip.
the duration. Yeah. Hi, Esther.
Hi.
I think the series that will look more into this and look into different vessels and types and but yeah, add on to you.
That you don't know. The duration of the trip.
Yeah.
We only know the landing date and the amount and where they land. And then yeah, we get the temperature from Hafrannsóknarstofa from their measurements.
Okay, that's a lot of crisscrossing talks here. Never mind, it was also mixing up two projects, but I'm just started wondering that whatever they are missing.
But couldn't you kind of calculate it based on the catch date or time of catch and then landing date?
That I don't know. Esther, what do you have? I mean, can you calculate it from the catch date and then the landing date, or you don't even know that?
No, we don't know that. We just know where they land, so we don't know when the departure from the harbors, and it's different how long the landing time is. We don't know when they're in harbor, when they're out. If that makes sense.
She kindly shared this. She was so amazing to share.
Yeah, okay, good. Anything else that we have to consider in the next phase here? Getting more data, refining it, validating the different parts. We will work with Magnus tomorrow. Yeah. Okay, good.
Yeah.
Just one final comment, or if no one wants to, but I think you mentioned already this in the morning, and now again, having the possibility to having the input of that person on the potential this decision-making side could be indeed very, very valuable. And perhaps we can take this role in trying to continue carrying on this conversation with Ingeborg, or have also someone from, or she could potentially help us to get, or help you to get another counterpart in Iceland, or at least it seems quite a good way to also try to explore.
Yeah, okay, good. Let's go on.
But we will have time to go back to potentially more questions after we hear from Nina, or even questions that relate to both presentations. So I will now give the floor to you, Nina.
I've already done a couple presentations on different parts of what we've been working on here in Iceland. So I will just sort of present a bit more generally about what we've been doing, why we've been doing it, and what our next work is going to be about in sort of more shorter and general terms. So just a little bit about myself, if there is somebody in the group that doesn't know us. My name is Nina. I'm a postdoc at the University of Iceland, and this is work I've mostly done with Guðrún Ólafsdóttir, who is my colleague at the University of Iceland. And what we have been looking at is, generally speaking, is circularity in blue bioeconomy value chains, especially to do with fisheries and aquaculture. And we've been looking at assessments, so what kind of metrics can be used to measure circularity. And then we've also been looking at sort of challenges. And of course, when you think about challenges, you start thinking about opportunities as well for improvement. Let's see. So a little bit, very little shortly about SmartChain. These are the sort of main issues we've been working on as a whole, as the project as a whole. And our part is mostly in the sustainable resource use and circularity, as I mentioned already. And we did, in the first part of the project, our colleagues did a lot of very good mapping activities, which we also used in our project. So I'll talk about that a little bit later. But the point was generally to try to figure out, okay, what can be done better? What can be improved? Can we have the industry tell us what needs to be improved? And can we come up with some kind of recommendations at the end of the project, both in terms of what the private sector can do, but also in terms of how the regulatory framework could be aligned better to the sort of overarching goals of circularity and sustainability. And we've viewed from the beginning, and I think this aligns a lot to, for example, how the European Union defines circularity, but also how it is defined in these countries that we've been looking in, which is Iceland and Norway, as a means to an end. So it's not really all about just becoming circular for the sake of circularity. It's about increasing sustainability and sort of contributing to this journey towards sustainable development, meeting goals that are basically international sustainable development goals, and then regional goals, which is everything that's coming from the European Union. And of course, Iceland and Norway are not within the European Union, but in Iceland, at least at least 75% of European law has been implemented. So, and everything that comes that has to do with environmental issues in particular is always implemented here. So I think it's very relevant to talk about the regional perspective. So the reason why circularity is being promoted is because the material footprint is growing and it's set to double by 2050. So we need to reduce that. And we need to reduce consumption. At the same time, we need to mitigate climate change. So increasing efficiency is an obvious goal. And often in the same sort of discussion, there's also the point that by increasing efficiency, you are also increasing profitability because you have reduced or no waste, and this helps also with the creation of value-added products. And we do have some experience in Iceland with value-added products actually increasing profitability. So there is good examples to work on. It's not really everything just in the clouds. It actually does work, not just on the slides, as an industry expert once told me in Norway. It doesn't only look good on the slides, it actually looks good in practice as well when you do it right. But of course, if you're thinking about a transition towards more circular economy, then you need to be using more renewable resources, you need to be reducing waste and emissions, and you need to promote the sort of efficient use of resources and recirculating those materials through the system whenever possible. And we'll talk about those cases where it's not possible later. And then you think about circularity, you have to think also about circularity in the context of bioeconomy. And what we're thinking about here is, of course, fisheries and aquaculture, and that's part of the bioeconomy. And that's the renewable segment of the circular economy is bioeconomy. And you can't have a circular economy without its bioeconomy sector, of course. And the bioeconomical sector relies on biological resources. We're talking about plants, animals, microorganisms, in order to produce goods and services. So, for example, fish on your plate. It involves all sectors and systems which rely on biological resources. And this is, of course, not just fisheries and aquaculture, but also agriculture, forestry, and biotechnology, among others. And it's all about sort of turning this what we call bio-waste, which we shouldn't be calling waste anymore, residues, discards, into valuable resources, and at least if that's not possible, then at least recycling those nutrients as far as possible. We're focusing more, I know I'm going into a lot of academic terms, but this is how we how we operate. So we are technically focusing on the blue bioeconomy in our project, but we are not only focusing on that in terms of when it comes to policy indicators and the general framework, because we're looking at the whole system. But of course, We want to look at aquatic resources and how those are utilized. And that's why we talk about the blue bioeconomy. And also because there is sort of research gap in this category, a lot of research has been done about the about the bioeconomy in general, but not so much about fisheries and aquaculture and how those sectors talk together with other sectors and how they work together in the general framework of circular economy. And in addition, because we are from Iceland and our colleagues are from Norway, this blue bioeconomy in terms of sustainable use of aquatic resources and ecosystems is a very important tenet for both these nations, partly because they depend so highly on aquatic resources in their economies, and partly because there is an outsized economic and cultural significance of those two sectors for these two nations. And therefore they receive outsized and significant attention in both the public and the policy spheres, maybe more so than in other countries that have more agricultural emphasis or so on. And in addition, these two countries are interesting cases because they share so many characteristics. They both have extensive coastlines, they have rich marine biodiversity, and they're both quite rich, so they are well positioned to play a leading role in advancing principles of circularity. And plus, they have highly advanced sectors. Norway, especially with aquaculture, in Iceland, we have also very high, not so high advanced sector in aquaculture because it's quite new, but we have a very highly advanced fisheries sector. And then, so in general, for us, the question was, how do you assess progress? Because there are a lot of numbers being thrown out there about how we utilize 100% of the fish and things like that, but we don't really have very, very concrete numbers behind those claims. And then we were thinking about what is progress in general? Is it just the fish utilization? Should it be a more general concept on what is sustainability? And then, of course, as I mentioned earlier, what are the sort of main challenges to increasing circularity? So we came up with an adapted conceptual framework from the literature. I won't go into this very much, but it combines principles of circular economy with the sort of value chain of the blue bioeconomy, especially to do with aquaculture and fisheries. And we added a little bit, some of the activities from our colleagues to do with mapping. What sort of products are we talking about? Or what sort of rest raw material are we talking about when we're talking about fish? So of course we're talking about head and bones and skins and viscera and trimmings and so on. And what sort of applications are we talking about? We're talking about the value pyramid. You start with the most valuable in terms of profit categories, which is pharmaceutical applications, down to feed ingredients, which you use to feed into, for example, aquaculture. And then you have other applications, which could be fertilizers and composting. And then you have sludge that you don't know, often just goes into energy production. Very few words about what has been happening since we started that hadn't been happening at the time, but was in the works. There is new European regulation on company reporting, which is going to be mandatory and is already being implemented by bigger companies. And this is regulation that has passed in Iceland. As I said, even though we're not in the European Union, we do implement these regulations. And what has happened is that you now have mandatory reporting for certain companies, especially in terms of size. And you also have new standards that the European Union has developed, or EFRAG has developed. And you will see here just this very short overview of the ESRS standards, the European standards, and one of the topical environmental standards is resource use and circular economy. So these issues are coming strongly into regulatory frameworks now, and it's important to consider them also for the corporate sector and the private sector. But this is valuable also to us as researcher because it means that a lot of data hopefully will be made public that we can then use for our scenarios and our simulation models and all that stuff that we like to do. So this was sort of the first part of our project, was to look at metrics. And we looked at this report mainly from the FAO, which is just general indicators for monitoring and evaluating the sustainability of the bioeconomy. And then we cross-referenced them with criteria for the blue economy from the European Union, from the Commission, which was newly released when we were doing our study. And I won't go into it very detailed, but we chose a lot of indicators from these frameworks, and we cross-referenced them with the GRI, which is the framework that companies have been using so far. Of course, this is going to change now with the European Union. And then we also looked at sector-specific metrics, and this is important because you have to have more specific measurement for certain sectors that are different as opposed to other sectors. So, of course, we have a lot of specific issues in aquaculture and fisheries that we need to cover with more specific measurement. We supplemented indicators we found in the Commission's document that were too qualitative, in our opinion, with something more quantitative. And it should be said that actually a lot of companies have quite quantitative indicators that they've been using, especially the large ones. And I should add also that the European Union will also come up with sector-specific metrics, but there has been a political agreement to delay those, and they will release them later. They've already released their draft, but they will release those later. And then what we did is we did a lot of interviews with companies, not just in the primary sectors of aquaculture and fisheries, but also in the supporting sectors and service industry. So even shipbuilders, packaging, everything to do with like that, biotechnology companies and so on. We had less luck with finding a lot of policymakers, but we did talk to a lot of experts that we could find from NGOs and other sort of research organizations that we could find. And we categorized these interviews and the data from the interviews into these 4 general categories: regulatory, resource issues, market, and social. And I'll just talk a little bit and very briefly about regulatory and resource issues, because that's sort of what we are going to be focusing on in the future, or what we're focusing on right now. And these are some of the data from Iceland, for example. You can see that also these 2 categories dominate the conversations we had with the industry. And the issues that came up in Iceland were also quite distinctively Icelandic. We have a lot of issues to do with infrastructure, for example. Waste management and wastewater management are huge topics that we have yet to tackle here, partly because we have a lot of rural remote areas in Iceland. And we've also had energy supply issues, and those relate a little bit also to regulatory issues, because we have been selling a lot of energy to a lot of, for example, data mining companies and things like that. So this is causing a bit of issue now. And then in terms of regulatory, also a Icelandic issue was that we do lack institutional capacity, and we do need more policy integration, and we need more long-term policy on bioeconomic issues in general and circular economy issues as well. And in Norway, you had this more general discussion on climate change and the effect of warming waters and what to do about extreme weather, and then also raw material issues in terms of all the export of unprocessed fish, which we discussed already earlier, so I won't go into it very long. And there was a call, especially from the service industry, for a more holistic approach, avoiding the tunnel vision of just focusing on carbon emissions and taking the more holistic view, and thinking also about effects and impacts, not just locally, but also globally. And of course, taxation was high in the mind of the people we interviewed, because there was this huge discussion about increasing tax for aquaculture at the time. And this is just our picture from before with some of the issues that came up from the interviews. I won't go into it very deeply, but you can always, if somebody here is not in the project, can always email us and get more information. And these are sort of the next steps. So we're going to use all these findings from the interviews in order to compile a paper on policy issues and governmental sort of level incentives and disincentives, and how the policy instruments are talking to each other. And it's a clear opportunity to do this now to improve both utilization and also circular economy principles. The best thing you can do is try to align different policies together. So if you have circular economy policies and you have energy policy and all that, you need to have them somehow aligned to each other so that there are no trade-offs. So a lot of what the European Union has been doing, for example, is sending a lot of biomass straight into energy production, and that's not what we would want to prioritize from a bioeconomic and circular perspective. You want to try and recirculate the materials as much as possible into the system, and you need to try to create as much value added as you can. And energy use should be the last resort. But this is not exactly what we've been doing. So that's what I think will come out of that. But we also have to look at CSR reports, so the sustainability reports by companies, and see what they have been reporting on. Is something of that useful for us? What are the sort of data we could use from there? But we are, of course, going through a lot of change now, and the next reports that will come out in 25, at least from those big players, will be with different standards. But it should be said that they are standards that are interoperable with the GRI standards. So it's a lot of them do actually align with each other. It's not that crazy new information that they're asking for. The new thing that is happening is that they're asking for double materiality, which means that they don't only want to know how does a company impact the environment, for example, but they also want to know how will the environment impact the company in financial and material terms. And that's sort of the major change in these new frameworks. So yeah, I think I already talked quite a lot. I'll stop now. Thank you very much.
Thank you. Now the floor is open for questions. Anyone would like to pose a question to Nina?
We had quite long meetings in Iceland last time, so.
Actually, I have a general question about one thing that you mentioned that we also see in other projects, is this reluctancy that sometimes policymakers have in taking interviews to talk about regulatory issues. So from what I could understand, you still manage to have a few on your, or
no, not policymakers, no.
No policymakers.
And that's surprising because in Iceland, usually the ways are short to policymakers, but it's not too surprising because from what I hear from these experts that we did talk to, who are working more at the institutions that are related to the government, but are not basically the ministry, is that people are just extremely overworked.
Okay.
So they don't really have a lot of time for things like that. But also what we are seeing now is that we have a government coalition that is not really communicating with each other very well. So it's creating a lot of tensions. It's not very easy.
Okay, that's quite interesting. Anyone else would like to ask anything? Yes, please, Sigurdur.
Hi, interesting presentations. Thanks to Ali for his. I didn't want to impose with any questions, and Nina, very nice question, nice presentation. And actually, I think we need to involve the policymakers in some manner, and whether we succeed to do that in the coming months, we just have to wait and see. But I think you are really on to something in your work. But to bring the policymakers in, either you have to have a poll coming up, they are threatened, or they see an opportunity. So maybe they need to see the opportunity.
We have elections coming soon, so.
Yeah, who knows? Maybe next summer. Thanks very much.
Okay.
Any other question?
No, just congratulate the presenters. It was really good for both of them, Ali and Nina. Great job.
Yeah,
Great
absolutely.
job. We agree. Just one quick comment or question. Wouldn't you agree, Nina? You said the last resort would be sending it to the waste or whatever, bioenergy plant. Wouldn't that be landfill? That's the last resort.
No, well, yes. I mean, landfill absolutely is the worst you can do. But if you're talking about circularity, then what has been pointed out is that your priority should not be energy production. Your priority should be value creation as far as possible before you consider energy.
Yeah.
And if you're just sending everything to energy, you're losing these opportunities to create good products, you know. So
yeah, I agree.
If I can add, actually, we were working with Italian guys, actually Nina and Guido were involved in the proposal. We didn't win the grant, but they have 71 bioenergy plants in one region in Italy, and they put all the food waste into bioenergy. So probably they have a long way to go to 100%. So 71 in a small region of Italy, 71 bioenergy plants producing on average 850 megawatts. So there is a huge waste of food resources into bioenergy.
However, they also use they also need the energy, singular, you know, because they shouldn't be too much friends with poop.
That's true.
Yeah.
It's different in Iceland because we have so much green energy that we should be using, and we don't have enough food waste because we're so few. Yeah. So the opportunity is a little bit different here. It's a different context.
But the interest is that when you work across Europe with partners in making proposals or even projects, you understand there are different constraints and opportunities in each region.
Absolutely.
Yes. Okay, then given the fact, I would like to close the webinar for today and the annual meeting. Thank you very, very much. It was very good work that we had the opportunity to hear today. And I'm also particularly happy with the fact that we had people outside of the project listening in, especially to our webinar. And if you don't have the emails of the presenters, either Ali or Nina, you can try to find them, but if not, you just send me an email and I will forward them directly to our wonderful presenters today. And once again, thank you very much.